Hello, and thank you for joining us for today's webinar. My name is Anil Krasian, and with me today is
Kevin Cochran.
And we're going to be hosting today's webinar. It's just going to be a kind of a high-level overview of really a differentiation, a listing, and some knowledge of the 4 different counterbalance valve families that we offer here at Sun Hydraulics. Thank you for joining us today. Before we really get into today's message, before we get into the main topic today, just a couple of brief housekeeping rules. Just want to go over a few things. When you joined the webinar today, your microphones were immediately muted. So we're going to ask that you go ahead and remain muted throughout the webinar today. That's actually so that we can all enjoy the best audio quality possible. And if you do have any questions that come up as we're going through the information today, we're going to ask that you actually refer to the GoToWebinar control panel. And over on the bottom right-hand side, you'll actually see a chat feature. That chat feature is where you would go ahead and send us in any of the questions that you might have. You can type those questions in at any time, send them to us. We'll be happy to go ahead and answer those as they come up. The webinar today is going to take about 30 minutes or so. And at the end of that 30 minutes, there will be ample time to go ahead and answer any questions you have. I do want to go ahead and make note of the fact that there were a lot of people on today's webinar. And so since there are so many people, there may be a lot of questions. If for some reason you did not get your question answered at some point in time during the webinar today, please don't worry. We will absolutely keep track of your question that you chat in. And we're actually going to keep track of your email addresses as well, and we'll certainly get an email response out to you just in case we don't have time to answer all of the questions today. So again, thank you very much for joining us for today's webinar on choosing the right counterbalance valve. So again, today is going to be that high-level overview. We're going to be taking a look at all of the different families of counterbalance valves that Sun Hydraulics has to offer, and we're going to be giving kind of a high-level overview of what each of these families are, what they do, what was the reason for having all these families of counterbalance valves. And with that said, I'd like to start out today with kind of a question, basically a poll for all of you that are with us today. So that question is really going to be based on this. If we take a look at our website, you'll notice that there are actually 4 different families of counterbalance valves. And I'm just on the Sun Hydraulics website, just sunhydraulics.com. And you'll notice that when you're in the cartridges section under the load holding, we have 4 different families of counterbalance valves. We have standard counterbalance valves, our load control valves, our load match valves, and our load adaptive valves. And so I just kind of wanted to start out today with a quick question that should pop up on your screen any moment now. And that question that's going to pop up on your screen is going to read something like this. The question is, are you confident in your understanding of the different families of counterbalance valves shown on the Sun website? So that poll is going to come up on your screen, and we're going to be asking you a couple of different polls like this today. So if you have just a quick moment, if you just take your mouse and go ahead and answer that question with either a yes or no, we'll go ahead and provide the answers to that quick poll. We'll provide all of the answers to you in just a moment. We'll show you how many people said yes and how many people said no. But the question again is, are you confident in your understanding of the different families of counterbalance valves shown on the Sun Hydraulics website? So as we're gaining the answers to that poll, we'll go ahead and we'll put that information on the screen for you in just a moment. But one of the reasons why we asked that question was really because we wanted you, our participants, to kind of see one of the things that we experience here at Sun Hydraulics. And what we experience here is that there are an awful lot of people that are interested in our counterbalance valves. However, sometimes it's a bit of a challenge to figure out exactly which family of counterbalance valves we should be looking at. Oh, okay, and so there's the answers to the poll. It's on the screen right now. 79% of the people that answered that question said no, they're not completely confident with their understanding of the different families of counterbalance valves on the Sun Hydraulics website. So that's actually the reason why we're here today, is we're going to actually try to answer some questions. We're going to try to go through some differentiation, and we're going to go ahead and discuss some of the differences between each one of these families, so that hopefully next time we ask that question, it won't be 79% that say no, we're not confident. It'll actually be a much lower percentage on the no side, and many more people will be very confident that they understand what's going on with the Sun Hydraulics website. So, Kevin, thank you for joining me today. Again, my name's Anil Krasian. We're going to go ahead and get started today. So, Kevin, over the last few years, Sun Hydraulics has come out with a huge variety of counterbalance valves. So we have 4 different families of counterbalance valves. We have a whole bunch of them out on the market. Kevin, why do we have so many counterbalance valves?
The answer to that is you need a lot of variety to find just the right answer to the needs of a particular application or system. Unfortunately, selecting the right counterbalance valve isn't a very simple equation. There's many, many different variables involved, and it requires a great deal of understanding that often isn't achieved until you've done some experimentation. So to try and make sure that we have a solution for every application out there, we have this very broad product family.
Okay. Well, if that's the case, and we have all of these different valves because we're trying to really resolve all of the different system options that could possibly be out there, let's start this way then. Let's take a look at all of our counterbalance valves, and I'm just going to ask you kind of a really big, high-level question. What's the most popular counterbalance valve that we sell and why?
Sure. The most popular counterbalance valves that we sell is still our standard counterbalance valves, the valves that have been around for about 40 years now, originally developed by Bob Koski and John Allen when the company was founded. And those are derived off of what were industry-leading valves at the time. However, Bob and John had worked a lot with these valves and knew that they had some shortcomings. So they wanted to try and improve on that already good design and build an even better mousetrap. So taking their knowledge of applications and application difficulties, they set out to create this better product. And at the end of the end result of that was the current counterbalance line. The most popular ones that we sell are still our T11A 3-port non-vented counterbalance valves, of which we have a very wide variety. And they're popular because they're very effective, they're very durable, they're high quality. For example, one of the design changes they made was the addition of the floating nose for the critical functional components. Many other industry common valves have a rigid nose that's attached directly to the body. The downside of that is if you have any defects in the cavity, it can seriously degrade performance in the field. By the addition of the floating nose, it gives you just a little bit of play in the cartridge, which will allow much better, more consistent performance in a less than ideal cavity. In addition to that, they took the cavity problem as a whole on, redeveloped it, came up with what's now the sun cavity, which allows for larger port hits, which result in lower pressure drops for similarly sized valves versus industry standard valves. And then on top of just the performance, they said, all right, well, let's go even a step further and let's bring a lot of these critical processes that are really dependent on producing a quality, durable product in-house. Let's understand them, perfect them, and make the most of them internally so that we can maintain very high quality standards that will result in very good performance and very high durability. And of course, all of that is available worldwide when you want it.
Okay. So it sounds like that's actually a great valve. And so, obviously my mind's going in a couple of different directions when you ask that valve, but I have to ask you, this last slide that we were on, we saw that there was a standard valve and also a vented valve. Tell me about what is a vented valve? What does that mean?
Sure. The vented valves are a special subset of what we consider a counterbalance valve. The standard, the most common counterbalance valves, again, are the 3-port non-vented. However, one of the drawbacks of those is that if you have back pressure in your system, particularly on port 2, usually from some sort of a meter out application or small line sizes, that back pressure can negatively affect the performance of the counterbalance valve. It can cause instability and other problems in the circuit. So one way to counteract that is to give an additional reference port, either internally with a 4th port or externally out to atmosphere, and that reduces or eliminates the sensitivity to back pressure, which can improve stability. The advantage of the 4-port is, which is the sun preferred option, there will never be any external leakage. The downside is, of course, you have to have another return line going back to your tank. The less preferred, but still a good option, is the atmospherically referenced version. However, you do have to keep in mind that you may get some leakage out to atmosphere at some point after extended use.
Okay, so the vented sounds like it's a good option for for a particular case, but we're going to be talking about basically 4 different families of counterbalance valves today. So are vented options available for all of those different families?
They are available for 3 of them. The load adaptive valves that we'll talk about later do not have vented options at this time. However, the other 3 all have vented options. They may not be as common or as widely varied as the standard valves, but there is always going to be a vented option available.
Okay, so the standard valves sound like they're a great valve, and you talked about the floating nose and some of the other finishing processes that we have in-house here at Sun Hydraulics that kind of make our valves special. So it seems to me, though, that we have, with so many, I think you mentioned it as like the depth and the breadth of the product line, we have a lot of valves that fall into that standard category. With all those valves, why would Sun do anything else? Why would we offer a different kind of or a different family of valves?
Unfortunately, even though we have such a depth and breadth and a wide variety of these functions, even that isn't good enough for some very critical applications or very difficult applications. Even though we have this wide variety of capacities and pilot ratios to try and find just the right balance of control for an application, every once in a while we find that that's not good enough. So about 20 years ago, they started to develop another line of counterbalance valves called the load control counterbalance. And this was a completely different construction than the standard counterbalance valves, specifically designed to try and be more stable through better modulation, and then more applicable to a broader range of application circumstances. So we've taken our knowledge of a good product and tried to come up with an even more clever, more robust counterbalance that could be applied to a wider set of circumstances.
Okay, so we went with what was already a good valve, and then some innovation, some design process happened, and now we have a totally different valve. Now, does this valve does it come from the same kind of design architecture as far as the going from a standard counterbalance valve to the load control valve? Are they based on the same design, or is this a completely different move?
It's a completely different internal construction. The basic philosophy of the performance is similar, but the way that we achieve it is very different, and that was done intentionally so that we could try and maximize the increase in stability.
Okay, so we went from a good valve, the standard counterbalance valve, which is still our most popular kind of valve on the market, and now we also have the load control valve, which seems to be more focused on stability and control, and that's great. So within those two categories, surely that's enough valves for you to accomplish just about anything. So why more valves?
Well, the answer is those two combinations will typically solve any sort of stability problem that you may have, giving you good control for any actuator, but there's still another concern, and that is efficiency.
Okay, efficiency, and that's a big word. So help me out here. What do you mean by hydraulic efficiency?
Sure. When we talk about efficiency in the circuit, we're really talking about reducing pressures required to perform work, effectively making the machine require less energy to do a job. For a standard counterbalance valve, any counterbalance valve really, you're making a concession, trading off energy for stability. It's a bit like driving a car with the emergency brake on. With the emergency brake on, you can be assured that when you take your foot off the gas, the car is eventually going to stop, but you're always going to be using extra fuel to overcome that drag from the brake while you're driving. The counterbalance valve works in the very same way. The counterbalance valve itself provides resistance to the actuator so that you're always in positive control regardless of how the load is trying to move it. But that results in a significant consumption of energy in the process. So we wanted to try and look at some clever ways to reduce that energy consumption while still giving you good control.
Okay, you said clever ways, plural, and I'm sitting here thinking, okay, we've already talked about our standard counterbalance valves, we've talked about our load control valves, so that leaves two more families of valves that we haven't discussed yet. Is it safe to assume that those last two families of valves are both focused on efficiency?
Yes, they are.
Okay, so big question for you. Maybe we should just go ahead and ask all of our participants today. Let's go ahead and put up another poll on the screen. In just a moment, you're going to see another quick question on your screen, and the question is going to read something like this. Do you know the difference between the two families of valves that are focused on efficiency? Do you know the difference between the two families of valves that Sun offers that are focused on efficiency? So take just a quick moment and go ahead and click on one of those answers for me. I tell you, one of the reasons why we wanted to ask that question is that at least one of those families of valves is still fairly new to the market, and it's one of those things that it may make a difference of which family of valve that you actually want to choose. And what we're going to do as soon as we get some responses back for this particular poll is we're going to go ahead and obviously show you the response to that poll, and then we're going to take a moment, Kevin, if it's okay with you, let's go ahead and talk about the differences between these two families of valves. Sound good? Mm-hmm. All right, so the responses are still coming in. I think we'll give it just one more moment here. It sounds like there are quite a few responses today, but my guess is that most people will not know a lot of the differences between those two valves. What do you think?
It's probably true, especially given the initial response.
Given the initial response. So the reason why we're asking a lot of these questions today and the reason why we're doing these polls is frankly because we know that these are some questions that are kind of widely spread out in the marketplace today. And as we can see from the screen right now, the answer is no. A lot of people just do not understand the difference between those two families of valves that are focused on efficiency. So Kevin, we have a tall order in front of us. We have to try and explain the difference between those. Are you game?
Let's do it.
Let's do it. Okay, so what's the first family of valves that we want to talk about today focused on efficiency?
Sure. The first one is the load match valves. This is the first energy efficient type of counterbalance valve we really tried to develop. We started working on these about 5 years ago. And they're based primarily off of the load control valves that we just discussed. So you're still going to get the benefits that we talked about there, where you're going to get improved modulating, which means better stability and improved control over a wide variety of applications. So it's going to be generally a pretty broad solution to many problems. However, in addition to that, we've created a new driver that controls the setting that self-sets to increase the efficiency of the valve. So anytime we talk about a counterbalance valve, the amount of pressure required to open it is determined by an equation that says the setting minus the load pressure divided by the pilot ratio. Assuming that your setting and load pressure are usually going to be fixed on a particular machine, which it would be, then the biggest variable becomes the load pressure. The higher the load pressure, the more efficient the counterbalance valve becomes. The lower the load pressure, or even at no load pressure, the more energy you're using to open the valve and get it to move. The load match valve addresses that by reducing the setting when the load pressure is low, so that it requires less energy to open it up and begin movement.
Okay, you said an awful lot there, so I got to ask a couple of questions because I honestly got a little bit nervous here right in the middle.
Sure.
So I got a little bit nervous because I'm used to standard counterbalance valves. And a standard counterbalance valve, you actually choose the setting of the valve based on load-induced pressure. Is that true?
It is.
Okay, but this new load match valve, you're telling me that I don't choose a setting for it. Is that true?
Not exactly. You
Okay.
you still do choose a setting. If you look at the website, you'll see that there are 3 different what we call thermal relief settings, which is the maximum pressure the valve will allow before it opens up and functions like a relief valve. So anytime you see those numbers, you need to still know the maximum load-induced pressure that you'll see in your application and choose the correct load match valve so that you'll always have a setting that's a maximum setting that's 1.3 times higher than the maximum load-induced pressure. For example, if I were to pick the 4,000 psi load match valve, I would want to make sure that my load-induced pressure would never exceed about 3,000 psi.
Okay.
However, below that, anytime the load pressure is well below that 3,000 psi, the setting of the load match valve will reduce so that you can maintain a much smaller pressure required to open it. So it's always going to try and find this optimum setting while still giving you good control.
Okay. So are you telling me that this is a good kind of a valve for something that has lots of varying loads?
Yes, absolutely. A good example would be, say, an off-road forklift or a telehandler, where you need a very high setting in particular to lift up and hold a heavy load. But most of the time, you're going to set it down on a platform and then bring the forks down empty. You're going to use almost as much energy to bring down the empty forks as you did to lift up the load with a standard counterbalance valve. With the load match valve, however, it'll reduce its setting once it senses that the load pressure has been removed, and you can lower the empty forks with much less energy.
Okay, so load match valves sound like they're incredible. We've already talked about our standard counterbalance valves, and that's kind of like the one that is always, encounters almost all of the situations that you might need. So there's a huge depth and breadth of that product family. And then we talked about the load control valves, which are really kind of more focused on stability for those challenging applications where standard counterbalance valve may not quite get the job done for you. So increased stability, increased control. But now you're telling me this load match valve is based on that same architecture as the load control valve, which really had a focus for stability and control. But now, even though it's based on that architecture for stability and control, it's really got a benefit, a bonus, in that it's focused on efficiency as well.
Mm-hmm.
So safe to say that it's also a very stable valve?
Yes.
So a stable valve that also focuses on efficiency. Okay, which begs the next question then, why would Sun have another category or another family of valves that's also focused on efficiency?
The answer there is, even though the load match valves are a great addition and an improvement on the load control valves, they still can't address every possible scenario or find the optimum solution to some scenarios. So to try and address the places where the load match valve may still not be quite the right answer, we've created the new load adaptive counterbalance valves.
Okay.
And these valves are specifically designed, they use the base architecture of those standard counterbalance valves, so you're going to get that legacy of performance that we've had through 40 years of development and refinement. Uses all the same internal components, so if you're very happy with the performance and durability of our standard counterbalance, this will certainly be just as durable for you. In addition to that, robust and well-proven mainstage, though, we've now added a dynamic or a pilot ratio driver that can go through a couple of different or 3 different pilot ratios to try and give you an increase in efficiency depending on where you're at in the application cycle.
Okay, so we've got load adaptive valves that we're talking about that are based on the same standard architecture as our standard counterbalance valves. So still a good, stable valve, now focused a little bit more on efficiency. And we had the load match valves that were also focused on efficiency. Can you tell us how would we use one of these valves to gain greater efficiency?
Sure. We have a quick example here to kind of go over a typical simple counterbalance application. See if we can get it. There we go. So here we've got a simple little application where we have a load that's being supported by a boom, and that boom is being moved by a cylinder. On the cylinder, to control its motion, we have two counterbalance valves in a typical crossport application. So in this setup, once we switch the directional valve, we'll begin to apply pressure to the blind side of the cylinder. That will go across the check valve on the counterbalance valve on the blind side at very low pressure, so we don't lose much energy there, and build up pressure until we start to move the arm. Here on the table on the right, you can see we have a simple little chart that's showing the pressures on either side of the cylinder. The right-hand column is the pressure on the inlet side feeding into the blind side of the cylinder, and the column on the left is the rod side of the cylinder, and that's the pressure that's eventually going to be going back to tank. So one point to note here is until we cross over the center point, we have zero load pressure acting on the rod side of the cylinder. However, once we cross over that, we will need the counterbalance valve there to try and provide control. At the moment, though, before we cross center, the counterbalance is really just in the way, and we're having to use a lot of energy to open it up and allow movement. The reason for that is we have to have a high setting on the counterbalance so that when we do cross over, we've got enough of a resistance to the motion to provide control, which is good. But again, right now we don't have that, so we're having to use a lot of pressure here to overcome that setting and begin to move. In fact, about half of the pressure you're seeing here is being used just to overcome the counterbalance and allow for motion. So although it's effective for control, it's not particularly efficient. And as we cycle through, you'll see that once we go past center, our pressure lines change, and now all of a sudden that counterbalance is in effect. We build up load pressure. The pressure required to move the application or to move the actuator drops down significantly because now load pressure is working in our favor. So if we wanted to save some energy here, we could just replace this counterbalance valve or both, depending on if the actuator is going to be moving back and forth. But by just replacing this counterbalance valve with either a load adaptive properly set or a load match valve that had been selected based on the correct maximum load induced pressure, we could see a significant energy savings because the resistance to motion up here when we have no load pressure would be significantly reduced. In fact, we would see these pressure values here come down to be much more similar to what we have when the counterbalance valve is actually controlling the load.
Okay. So by simply swapping out a valve, we can actually make a system a little bit more efficient.
Yes.
So that begs the question then, are all the counterbalance valves that we have, can we just easily replace one for another?
You can typically find a different functional type that will fit into the same cavity. With some of the new products, the load match and the load adaptive, the family lines haven't been completely fleshed out yet. Give us a little bit of time, check back often, but typically, yes, if you have a T11A cavity, we will have a standard counterbalance valve that will fit that, we'll have a load control valve that will fit that, and we will also have load match and load adaptive valves that will all fit into the same cavity without you having to redesign the circuit.
So generally the same cavity, but we could put in one of 4 different families of valves.
Correct.
Okay, nice to know. All right, so we've talked about our standard counterbalance valves, we've talked about our load control valves, we've talked about our load match valves, and we've also talked about our load adaptive valves. And we've given you kind of a high-level overview of how you can differentiate between each of those families of valves. But Kevin, in all of that was a huge amount of information. Is there a quick way that we can just get our minds wrapped around the differences between each family of valves?
Starting with the standard counterbalance valves, again, this is the tried and true, the really proven technology that the industry's come to adopt and consider the standard. And for these, it's typically going to be your first thing or your first counterbalance valve to consider, simply because it does have that depth and breadth of solutions. You'll find the widest variety of pilot ratios, the widest variety of capacities, and the widest variety of functions in the standard counterbalance valves. So it's always a good place to start. If you've already used a standard counterbalance and found that even with that depth and breadth, you haven't been able to find a good solution for your stability, or if you have an application where a previous experience tells you you may have a problem with stability, then it's time to consider the load control valves. And for those, again, you're going to get that improved stability because of the improved modulation, and you'll get generally better performance over a wider variety of applications. So if you're not really sure about the application, you think it might have some stability issues, maybe a better bet to just try the load control first.
Okay.
So beyond that, we have the two new ones, the load match and the load adaptive. And the general thought there is if you're coming at the problem with efficiency in mind, you want to save some energy, the similar logic holds. So if you're already using a standard counterbalance valve, you're happy with the performance, you'd just like to save a little energy, that would be a great time to consider the load adaptive counterbalance valve. Same functional characteristics, just more efficient. If you're in an application where you've already found that you needed the load control valve to try and maintain good control and stability, and you'd like to save energy, that's when you would want to consider a load match. Beyond that, they both have some key advantages on their own. The load match, for example, has a fixed setting that's tamper-proof, cannot be adjusted in the field, cannot be tweaked in the field. So if you have an application where maintaining a precise setting is critical, it's great for that. It's also very good in terms of adjusting itself, so you don't have to fiddle with the counterbalance setting to find just the right setting for optimum performance on the machine. And of course, the improved energy savings. The load adaptive valve has another advantage. It is adjustable, like our standard counterbalance valves. You can get it with an L control, so you can fine tune it to get very good control at almost any setting. That's particularly good at load pressures below 2,000 psi. If your maximum load induced pressure is never going to exceed 2,000, you're probably going to be better off with a load adaptive valve. Also, if you need a manual override, that's a great time to consider the load adaptive valve because since it is an adjustable valve, you can carefully reduce it down and allow the actuator to come down without the assistance of other pressure or some other signal from the system.
Okay. So that's a huge amount of information today, and I hope you enjoyed getting all that information, but I know that we may not have addressed every single thing that's on your mind. That said, I'm just going to ask you right now, if you're on this webinar today, if you have some questions, now is a great time to go ahead and use that chat feature and go ahead and chat those questions in. And as soon as we start receiving some of those questions, we'll go ahead and respond to those as we get them. As we're waiting for you to think about any questions that might come in, we'll go ahead and actually we can have one ready right now. So the question just came in and it reads this way: is torque based on pressure setting or constant and not dependent on the max pressure setting? Kevin, what do you think?
Let's see, I'm assuming he's talking about the torque on a motor with
really?
I would assume he's talking about the torque on, say, a motor with a counterbalance installed. You can use the counterbalance to control the motion of a motor actuator as well.
Okay.
And on that, really, the counterbalance valves are there to just control the motion. They're not going to control the torque specifically. However, the setting of that can have an effect on the torque. Again, you're going to be using some energy to open up the counterbalance valve that you then won't be able to do additional torque on the motor. So by going to a load adaptive or a load match, you should be able to get more torque out of the same actuator.
Okay. So it sounds like if there's any further follow-up question that needs to happen on that, please feel free to go ahead and chat that question in. Looks like we probably have a few more questions coming in, but here's another one. Do you have a comparison to winter valves? Customers many times choose the cheaper valves, and we do know that winter valves are out on the market.
Yep, they are a lower cost valve, and we do periodically get in samples and check them against our own performance for both differences in performance and differences in quality. In general, our valves still function quite a bit better. We have lower hysteresis, better reseat values, and certainly a more broader product offering than they have. So in general, Sun is a better product than the winter valves.
Sure. Are you going to talk about any specific applications where we would use each type of valve?
Sure.
No, well, we could, I guess.
Yeah,
Would
we
you
could
like
give
to...
you a couple of examples. The load match valve, a classic example that we've used is the off-road telehandler. Or a forklift, but it really applies to anything with a winch, a crane, anything where you're really going to be moving a load that requires a very high setting, but oftentimes the actual working pressure will be significantly lower. The case study that we actually did was on a rail yard crane that was used to hoist up and down shipping containers. And you need a very high setting on the counterbalance valve so that you can hold a fully loaded container, but most of the time these containers aren't fully loaded. In fact, they're probably only half loaded, maybe less. And even beyond that, much of the time the crane is coming down completely unloaded. So again, you're using a lot of energy to overcome that counterbalance valve and lower the setting. By swapping out to the load match counterbalance valve in that particular application, we found that just by changing the cartridge alone, we were able to save 20% in fuel over a typical duty cycle.
Okay.
Similar logic would also apply for the load adaptive valves.
Okay. So what about standard counterbalance valves? I mean, I don't know that we need to really get into a specific application with that. It seems like it's a very broad concept.
Yeah, I would hope so. Anytime, though, you have an actuator, be it a cylinder, a motor, anything along those lines, and you want to lock it, that's when you want to consider either a PO check or the counterbalance valves, particularly counterbalance if you're going to be modulating it, if there's nothing else to control the motion.
Okay, so I think we've answered that question, but if you do have any further questions that are on that particular line of thinking, maybe you could clarify a little bit, send us a kind of another response via chat, and we'll go ahead and try to address that if we can. I know that some of you are probably still thinking about different questions. Feel free to chat them in if you've gotten all this information and you can't type fast enough right now, or you'd like to contact us later. You can certainly do that. I'm going to recommend a couple of different things though. As we get closer to the end of the webinar today, we're still going to answer a few more questions, but I do want to show you that there are lots and lots of distributors out there in this world that would be more than happy to answer a lot of these questions as well. And so we actually just want to show you that directly from the Sun website. If you're interested in finding a distributor near you that can help you out, you would simply visit sunhydraulics.com. You would click on the contact section, and you would actually just click on this for quotations and purchases. And the reason why you would do that is so that you could find a map location that makes sense for you to go ahead and find a distributor near you that could answer some questions. So all you have to do is click on a map or type in a zip code or select a country, and you would easily be able to click on a link that would actually show you what distributor would be able to help you answer any of your questions about some of the topics that we've discussed today. So I see that another question has come in, and the question reads this way. Sometimes customers have problems with stability of load control, and we need to go back to standard. Not sure where that's going. I'll let you.
Well, what that goes back to is, again, the complexity of applying a proper, or choosing just the right counterbalance valve for an application. Are the load control valves typically more stable under a broader set of circumstances? Absolutely. However, that doesn't mean that they will be the right solution for every application. Time. And that's what we mean. We'd really love to tell you that there's this simple answer to pick just the one right magic counterbalance valve. And as soon as we develop it, we'll let you know. But until then, we can give you recommendations for the best selection, but the only way to know is to try it. And of course, when you do find a situation like that, please contact us. We love to hear feedback about that. That's how we understand the problems and ultimately make the products better.
Sure. So I think there's a follow-up question. We used the term modulation earlier, and
sure.
I think, so someone is asking the question, could you elaborate on what you mean by the word modulation? I'm going to assume that means in our load control.
Load control, even counterbalance valves, all of them are modulating, what we would call a modulating device. And by what we mean by that is you're applying a signal that's then going to result in a specific motion. And the way that signal affects the motion is what we're calling the modulation.
Okay.
Typically, you would also hear that referred to as, say, a gain characteristic. And specifically with the load control valves, when we say it has improved modulation, what that really means is it has a lower gain. In other words, it's less sensitive to changes in that input signal in terms of the motion. It's going to be more stable because fluctuations in that control signal have less of an impact on the way it's allowing the actuator to move.
Okay. So again, if you have any follow-up questions to any of the answers that we're giving, it's a great thing to go ahead and chat those in. Or again, I showed you, and I can show you again how to find an appropriate distributor near you that can help answer some of those questions. And they would also be a good contact in order to purchase any of these valves. You would need to actually go through a distributor that is close to you. Another question just came in. It says, please explain how to choose the proper pilot ratio.
That's a good one. Yep. And of course, as with all the other answers, it's not exactly straightforward. So a simple answer, the answer that most people go with is they try the 3-to-1 ratio first. Now, that's not always going to work. As a general rule of thumb, the higher the ratio, the more efficient the valve becomes, but also it can become more unstable. The lower the ratio, the greater stability, but the higher the energy required to get the load moving. So 3-to-1 is usually a good place to start. We're working on some tools internally that hopefully we'll be able to talk about soon that may give you a better idea of what pilot ratio to select. In the meantime, though, if you're really unsure, I would say gather up all the information you can about the application and then talk about it with your distributor or contact Sun directly, and we can help steer you to a more educated answer.
Okay. So that was a great question about pilot ratio, and it's kind of a common one. And it's one of those things that it is a challenge to get the correct setting and the correct pilot ratio to make that system work. So lots of options out there. Another question just came in. Why don't we just use the load match or load adaptive over the standard or improved control version from now on? That is a great question.
Very good
Why
question.
don't we just use load match or load adaptive valves?
Well, I would certainly say to keep it in mind and always consider it. Efficiency is only becoming a larger and larger concern for all sorts of industry. That being said, they are both more complex solutions to existing problems, which then requires a higher premium in terms of price. So although they are better valves, and I definitely recommend considering them, price is always a concern, so you have to take that into account as one of the trade-offs in the design process.
So our standard list prices are available on the website. Obviously it's one of those things that you want to take a look at, and sometimes a cost-effective solution is more appropriate for your need, and sometimes, the load match and load adaptive, which honestly, from an efficiency standpoint, do they ever pay themselves off?
Yes, absolutely. It depends on the application, of course, but the case study that we did that I was referencing with the railroad crane, we estimated that based on that 20% savings, the load match valve would have paid for the difference in price between the valve it replaced in only 40 working hours and would have completely paid for itself in 80. And then anything above that is savings directly into the customer's pocket.
So sometimes efficiency is a concern, and if it is, then definitely the load match and the load adaptive valves are the right valves to look at. They're great valves.
Yep.
Okay, next question that came in. Are the leakage for the valves the same, or does it differ from each valve type?
The answer there is they are the same. All of our load holding
valves.
The load holding valves are all rated for the same kind of leakage, yes.
Do you know what that is off the top of your head?
The standard value for the CBs is 5 drops a minute, and then the equivalent for the load match valves is 6 drops a minute. Both still fall within the load holding category.
Okay. So a safety device to hold people up in the air. So I guess that's the scenario that we're given. How is the setting able to change yet still be reliable enough to depend on?
Good question. So the answer there is even though the setting is changing, it's always approximately 1.3 times above whatever that load-induced pressure is. That's the rule of thumb that Sun has always promoted to try and find the optimum setting. In the past, though, you could only choose that based on that maximum load-induced pressure. Depending on the kinematics of the machine or how large the fellow that's being held up in the air is, let's say, that pressure may be quite a bit different.
Yep.
So the load match valve can then lower its setting, but still be safely high enough to guarantee safe load holding.
Okay, so that was a great question and a valid one, so thank you for asking. Another question just came in. Can you talk about the different ratio, so I would assume different pilot ratio, in applications?
Yeah, there again, we kind of go back to the selection criteria. Typically, the higher the ratio, the more efficient the valve becomes, but the less stable it becomes. It becomes much more sensitive to those fluctuations in the control signal. Again, the gain just kind of goes through the roof. So although the tendency would always be to use as high a ratio as you could, or as high a ratio is available, it may not result in good performance. So there again, something more along the lines of a 3 or 4.5 to 1 are good places to start, and then you may have to do some experimentation from there without having a really good model or understanding of what the system needs.
Is it safe to say that the dynamics of the solution actually play a part in what ratio valve you should choose?
Absolutely.
Okay, so if you're in a situation that's inherently unstable as it is, obviously a 5-to-1 valve may not be a good choice.
Right. Typically, then you're going to err more towards the lower ratios.
Okay, there we go. So another good question. That's one of those things that every single situation is a little bit different, and so difficult to give you a firm answer there. But another question came in. Are there any key indicators in the part numbers that distinguish between different families of counterbalance valves?
Yes. So the standard counterbalance valves are always going to be represented by the first 2 letters being either CB, CA, or CW. Those are the traditional product lines that we've had out for approximately 40 years, depending on the type. The load control valves are going to be represented by the first letter M, and it's either going to be MB or MW, depending on the functional type. The load match valves also start with M, but they will have the 4th letter as P, and that designates that new load match function. And then finally, the load adaptive valves all begin with CE. So if you're familiar with our model code today, let's say you're using a CBCA, which is the T11A 3-to-1 counterbalance valve and you wanted the load adaptive valve, you would order the CECA instead. Just replace that one letter.
Okay, and remember that as you're looking at these valves on the website, they are automatically separated into these different families for you. So counterbalance, load control, load match, and load adaptive. So if you have kind of a high-level understanding of which, what each of these families is really designed for, what it's really meant for, it's a pretty easy thing to go ahead and just select that particular family and then start using your system criteria to find the appropriate valve. Okay, next question came in. It says load adaptive varies the pilot ratio to increase efficiency, and I guess that's a question. So do the load adaptive valves vary the pilot ratio to increase efficiency?
Yes, they do.
Yes, they do. So how do they do that?
They do that based on monitoring the pilot pressure, whereas the load match valves are modulating the setting or adjusting the setting based on the load pressure. The load adaptive valves actually change the pilot ratio based on what the pilot pressure is doing. And what that does is it allows for a higher ratio when you're applying a high pressure signal, which typically means that you're trying to get that valve out of the way. You're not trying to do the fine motion control with it anymore. You just need it to get out of the way so that you can pass the oil across it more efficiently. Now, in terms of when you would use one or the other, I'm going to assume that you're talking about load adaptive versus load match. And there again, if your load induced pressure is never going to exceed 200 PS or 2000 psi, the load adaptive valve is going to be a much better choice. If you really need to be able to finely adjust the pressure signal, or the pressure setting rather, the load adaptive valve is going to be a better choice. However, if you need a very, very high setting, or you have a high setting and you know that your load pressures are going to vary significantly, that's when the load match is really going to stand out. And a key feature to note about the load match valves is one of the standard settings available is 6,000 psi, which is higher than most of our other load holding valves. So you can get to much, much higher pressures with the load match valve.
Okay. So, and if you have any follow-up questions, again, feel free to go ahead and chat those in, or again, contact your local distributor. We can show you, again, where to find your local distributor. Another question just came in. What does Sun recommend regarding the volume between the actuator and the counterbalance valve?
The answer there is yes, you want it as small as possible. That's the safest typical response, and there's two reasons for that. Number one, the smaller the volume, the less likely you're going to have a breach between the two, which would remove or eliminate the counterbalance valve's ability to maintain that actuator from moving. The other is the capacitance of the system does have something to do with stability. Easy answer there is yes, lower capacitance is good. However, if you really want to dig into the mathematics, there is some give and take on that. But in general, you would like the counterbalance valve to be as close to the actuator as possible.
Okay. So here's a good question that just came in. It's a valid question. The question reads this way. In general, when is it more appropriate to direct a question to a distributor versus directly to Sun Hydraulics? You want me to handle that one?
Absolutely.
Okay. So honestly, we would love for you to ask your questions to your distributor. They're going to be your source for the ability to purchase that valve or whatever piece it is from Sun Hydraulics. We're a manufacturer, and we would love to help you out, and we're always willing. So if you contact us through email or by calling us, we're going to help you to the best of our knowledge. However, since we don't have knowledge of all of the different applications that are out there on the market, your local distributor probably has a really good understanding of what it is that you're working with, and they actually have the tools, the technology, the talent, the system engineers in place right now that would have a better understanding of your particular application. And so if a distributor has that knowledge of your application, then they're going to be your best bet, your best source to answer any questions. Sometimes, they will call us as well because we need to get some specific product information to them. We're always willing to help. But the general rule of thumb is that the first line that you would want to discuss any of your questions with, whether it's an application question or a Sun product question, that first line would actually be your distributor. They're actually going to be your best friend when it comes to choosing the right valve and applying it appropriately. Good with that one?
Mm-hmm.
Okay. Another question just came in. Are there ISO fluid cleanliness levels required the same for the more efficient load match and load adaptive valves?
The answer there is we don't require you to have a cleaner oil than we would otherwise recommend for using the load adaptive and the load match valves. If you're meeting the recommendation that we have on the website today, that's adequate for those valves as well.
Okay, another one came in. What is the difference between standard and semi-restrictive valves?
Sure, there's a good education point. So When we say standard, restrictive, semi-restrictive, and even ultra-restrictive in some cases, what we're referring to is capacities for counterbalance valves that can fit into the same cavity. And this is one of the great depth and breadth features of the Sun product line. So for the standard counterbalance valves in particular, we typically have a variety of capacities in the same function that will fit into the same cavity. The standard capacity is going to be the highest rated capacity for that. And if we're talking about Series 1, the T11, that's going to be 15 gallons per minute. There will also be the semi-restrictive, restrictive, and ultra-restrictive, which then still fit the same cavity, but cut down the capacity to lower values. The difference internally is we have smaller milling, smaller connecting paths through the valve while you're doing that modulating, while you're actually doing the motion control, that physically make the valve more restrictive. It causes additional pressure drop to go through it. The benefit for the customer is, unfortunately, it's not uncommon to accidentally oversize a counterbalance valve, and that can often result in instability. So rather than having to redesign the cavity, let's say, and go to a smaller valve, we have these smaller capacity options that fit into the same cavity that will then typically be more appropriately sized for the actuator and still give you good control. And that's really what we mean by the restriction type.
Okay, so you mentioned something about a valve that's oversized. So the question I have for you is, I have a specific capacity of my system. I know what that capacity is, but as I'm looking at counterbalance valves on your website, maybe there isn't one that happens to be the exact capacity I'm looking for. Do I oversize the valve or undersize it?
It is always safer to undersize.
Always safer to undersize the valve.
Yep. It's when we're talking about control and safety, all those concerns trump efficiency. So it's much better to go with a valve that's slightly undersized and get better control so that you're never going to put somebody's life or property in danger than it is to try and chase efficiency.
Okay. Next question came in. Is cross-pilot to open check, is cross-pilot to open check, oh, there it is, has the most of the efficiency for simple load holding? In other words, is a cross-pilot check the most efficient for load holding?
In terms of efficiency, yes, a high ratio PO check or pilot open check valve, yes, would be more efficient. However, unless you have something else in the system that's going to control the motion of the actuator, they can be very dangerous. So although yes, it is more efficient, you have to be much more aware of what you're doing to control the actuator through other means.
Okay. Another question came in. So with the load match and the load adaptive valves, we consider heat as a loss of efficiency. Isn't there still the same amount of heat buildup with these new valves as opposed to the standard?
No, and the answer there again is because we're using lower pressure to drive them. Typically when we talk about heat generation, two of the primary factors you look at are the flow rate across the valve and the pressure drop at the time. And from those you can sort of build up a work energy envelope, let's say. So by lowering the pressure across the valve, even at the same flow rate, we're going to generate less heat and therefore consume less energy.
Okay, good question. Good question. So I think we still have a few more coming in. We're waiting on the next one right now, so we'll give that just a moment. Okay, and here's the next question. What does capacitance mean with respect to counterbalance valves or hydraulic systems?
That's what happens when you start using technical words.
Here we go.
So capacitance in this case refers to the compressibility of the system. A good way to think about it would be the difference between a hard plumb stainless line versus a length of hose, the same volume or the same length. The hose is going to have higher capacitance because the rubber itself is much more pliable. It can expand more, so the system can compress more and store more energy. Typically, lower capacitance will result in higher response and better control.
Okay, so it sounds like we still have a couple more questions coming in, and that's good. I do want to remind you that if for some reason you need to contact your distributor, again, just from the Sun Hydraulics website, you would just click on Contact. And for quotations and purchases, you just click that tab and simply find your local distributor. But we'll go ahead and keep taking some questions here and see if we can answer as many as possible. The next question is, occasionally we have redundant counterbalance valves as a backup in the event one gets stuck. Would load match or load adaptive valves still work if they were in series?
Yes, they should. Under that circumstance, though, I would make two caveats. One is, since you're going to have a restricted device downstream of the counterbalance valve, I would highly recommend that at least the actuator or the counterbalance closest to the actuator is a vented version of some sort. Otherwise, that back pressure from the secondary counterbalance will wreak havoc on the system or on the expected performance. And then if you're really doing the sort of belt and suspenders approach, if you're, can count on the load match or the load adaptive valve to really control the load, you might be able to get away with a higher ratio valve as the backup so that you wouldn't have to have, these other two load match or load adaptive valves, perhaps a bit more cost-effective solution.
Yes. Okay, so not sure if there's any other questions coming in. We're going to give it just one moment. Here we go. One more question. When using counterbalance valves on wheel motors to provide braking on a vehicle that has a varying load, is one valve better than another for braking on wheel motors?
Not really, I would say, in terms of performance. I'm not really thinking of a particular example that would, really make one stand out versus the other. If you're going to be using the CB valve as the brake, at some point it's going to be going across the relief element. And then it really just depends on how quickly you want it to stop. Typically, the load control valves and load match valves will have a steeper relief characteristic, so they'll provide more resistance faster than the load adaptive or the standard counterbalance valves. That's a interesting one. If you'd like more on that, please contact us and we can talk about it further.
Okay. Well, thank you all for joining us. I know that there are probably a few more questions out there, and we'll certainly go ahead and respond to those questions, but we're going to need to start responding to those questions via email just because we're simply out of time. I just wanted to thank you all for joining us today. I think it was a valuable period of time, and hopefully we've given you something to think about and given you some information that has benefited you. I do want to point out that our email address is on the screen right now, and again, if you've chatted any questions into us and you would like us to respond to those, we're going to respond to all of the questions that were chatted into us that we didn't get a chance to answer during this live webinar, okay? But because we respect your time, we're going to go ahead and end now. I do want you to know that you've got our email address as well, and you know how to locate your local distributor, so please feel free to drop us an email over at suninfo@sunhydraulics.com. Again, that is suninfo@sunhydraulics.com. We'd be happy to go ahead and answer any questions that you have via email, and again, we're going to go ahead and respond to every one of the questions that was chatted to us. We'll make sure that you get a response to those questions, and if you have any further questions even after that, we'll continue that dialogue and make sure that you are satisfied and comfortable with the answers that you get. So again, thank you very much for your time. We've enjoyed our time with you today, and with that, we'll go ahead and end the webinar. Have a great day.
Yeah, thanks. Goodbye, everybody.